Hi, my name's Gareth, and I'd like to share with you our meme-tastic story of operating Docker containers, an alternative paradigm to scheduling, scaling, and monitoring them. But first of all, I'd like to take you all back in time to the early noughties when a young, unmustachioed man walks into the technology center of an international telco. And he sits down at his desk, and his supervisor, Spencer, hands him a hard disk in a drive bay to plug into his computer because hot desking was serious business at this company, and tells him to install Gentoo Linux from stage 1 install because building an operating system from scratch will be a good learning exercise. And then when they're done, the pair of them can go over the script which Spencer had been working on to test the provisioning of new connections on a Cisco 10000 series router. Now, we never made it to that script because that was the first time in my life that I'd ever compiled an operating system. But it was also the first time in my life that I was suddenly introduced to working with some really highly skilled engineers and architects who were doing DevOps things before DevOps was even a thing. You could say that the team were ahead of the curve with a number of things. We were running resilient containers in production 10 years ago. And I personally built a small self-service virtual machine infrastructure. Apparently, word got out and 1 or 2 companies ripped off my idea. You might have heard of them. So just staying on history for a moment, try and get everyone woken up a little bit. Has anyone got any idea when containers were first introduced? 2005, any other takers? 95, maybe a clue? 1979, we got the Cheroot system call. In fact, there's been a number of iterations over the years, but with the introduction of cloud computing, containers sort of fell out of interest a little bit, really. Cloud computing just generally had a lot more enticing features. However, new design patterns, the realization for some companies that at scale, public cloud computing can be quite expensive, and the introduction of Docker means that interest is pretty high again. Unfortunately, our little whale friends, like sharks, aren't exactly native to clouds. On our most common model of cloud computing, there's a number of challenges. Maintaining the underlying virtual machines when actually now they're generally ephemeral and considered disposable. And port mapping, service ports to container ports, and all sorts of ways of monitoring which has come around, which has had to introduce new challenges itself, like running privileged containers or having access to underlying virtual machines when you might not necessarily always have access to it, and hooking into the Docker socket. So a number of solutions have come around to these problems and been invented, but they usually require you to build a lot of extra systems and maintain them. So if we look at Kubernetes, for example, that's quite a significant piece of infrastructure on its own. It brings in layers of complexity, required support, and extra knowledge you've got to pick up. And then sometimes you're going to have to put effort into integrating your applications with these frameworks. So it's no wonder that there's not a huge amount of stories out on the internet of people running significant container infrastructures at scale. What was once simple now has layers of complexity. For years, containers also got the benefits of bare metal performance, but with most cloud providers, they'll add in layers of virtualization, so you don't really get that either. So the main point really is that if you're going to look to start building out container infrastructures, make sure you try and keep all your supporting infrastructure as simple as possible, because you might find later down the line your ops guys are potentially holding up a big layer cake. Personally, I believe in the KISS approach. I believe that we can all run infrastructure as simply as possible and get as much value as possible from our supporting systems as we do from the systems that our customers interact with directly. So, why is it that so many companies, you see it on Gartner reports and IDC reports, put containers really high up on the list of things that they want to do with their business in the coming years, in the future of their business? Well, standardization is a big one. Docker has introduced a really neat way to package your containers into lightweight and easily shareable images, images that are portable from dev to prod, on-premise to public cloud, one cloud to another cloud, and they make that extremely easy to do. And even though many environments don't offer on-the-metal performance, there are some cloud providers that do that, and there are performance gains elsewhere from running containers, like startup times, for example. And if we utilize the underlying virtual machines effectively and keep our supporting infrastructure as simple as possible, the reduction in total cost of ownership can be great. So let's continue our story a few years later. We were working on a big migration project for a music company, moving out their on-premise equipment to AWS. There suddenly came a point where everybody united on the fact of the warnings that we were giving them about the hidden costs of public cloud. The company had a $150,000 a month AWS bill, and there was a significant amount that still had to be moved out to the cloud. That could have opened up a brand new data center for us every month, maybe every couple of months. The problem with that was that the company had got quite attached to all the functionality and agility that the public cloud was offering, and there was nothing really on-premise that was going to give us that. So a number of projects kicked off to try and help reduce the costs. Containerization was one of those projects, and Docker became a major technology choice. It had also been decided that we would have a hybrid cloud. The reason for this was the company had already paid for the physical assets they had in the data center, so they were going to sweat them as much as possible. Using containers was going to make that much simpler to do because of the portability that we get from them. I was involved in the project, and let me tell you, we definitely bumped all of the common pains that people usually do running containers. We didn't actually try puppies, but let's have a little bit of a look at our infrastructure anyway. It consisted of bare metal machines, EC2, AWS services, Zabbix, and all of the other things that you see up there. The developers of the company like to use DropWizard and send push metrics to Librato because it was easy for them through the development process. And we made a decision as a company to not open up our metric interfaces externally. So to get metrics into our event management system, which was Zabbix, we used a combination of Zabbix agents that were running locally on the virtual machine, connecting to the metric interfaces, and pulling the metrics all individually. Now, this was fine on large machines in the data center, but as we moved to a service-oriented architecture where the virtual machines got a lot smaller, and we actually started increasing the number of metrics we had on our applications, we started to see performance issues. We started to see CPU issues. And then, because all the metrics were being collected individually, when we were wanting to compare and calculate some metrics, we were getting a windowing issue, and we were getting results that we weren't expecting. We actually looked at pushing metrics to Zabbix using DropWizard as well, but at the time there was no libraries available that utilized the Zabbix discovery function. And that was an important part of our design principle to reduce management overhead. We eventually developed one, but in the meantime, we still had to pull our metrics individually, and actually maintaining this library was just effort that we didn't really want to have. We didn't like any of our options to work with tiny containers. Now, luck would have it, whilst I was doing some other general research into containers, I came across the AUTOPILOT pattern. And it's an important part of the paradigm, so we'll go and discuss it a little bit. Developed by a company called Joyent, who are part of Samsung. Some people might know them from Node. Joyent have been running on the metal container native infrastructure for 10 years. And the AUTOPILOT pattern is a fundamental part of the paradigm. It's a deployment pattern that primarily decouples your containers from complex frameworks and leaves only two fundamental components: service discovery and application orchestration, both of which are automated by a small piece of code which sits inside the container and automates operations. This is the life cycle of the AUTOPILOT pattern, or sorry, an application container on the AUTOPILOT pattern. Try to get my microphone in the right place. So, down the bottom here, we have console. Some of you probably know console. It's a service discovery platform, key value store. And we have container pilot here, and this is our small piece of code that sits inside the container. Now, with container pilot, we get a number of different handlers and functions. We get pre-start, and we get post-stop, and we get health check. So pre-start and post-stop handle things before and after the application's running, and health check is a health check. We also get on-change. On-change is all about reconfiguring our application if anything in our environment changes. Now, things that might change in our environment might get picked up by other things that Container Pilot's doing. It takes responsibility for querying console to about any services that it's dependent upon, upstream services, and if anything's changed, calls the on-change handler and reconfigures our application. Whilst it's doing this, it also takes responsibility for posting information about this application and any information about the container to console so that downstream services know how to communicate as well. We have some favorite features about flying on Pilot. Firstly, we're decoupling our applications and infrastructure, which means we have far fewer restrictions on our architectural designs. We can containerize legacy applications because Container Pilot is running inside the application, can listen to common Unix signals. The orchestration code is now the responsibility of the developers, who generally know best how the application should act. And they can keep that code in a single repository along with the application. We're basically 12-factoring our infrastructure. We have drastically less management overhead. And we have co-processes. The recommended Docker model for running application containers is to have just one process inside a container. But I'm yet to find a really compelling reason to do this. Putting agents inside gives us a number of features. It allows us to manage our containers more easily, it decouples us from all sorts of systems, and allows us to do things like automatic registration, automatic discovery of container resources, automatic discovery of upstream services. And by putting a monitoring agent inside the container, we can isolate and carefully control what our monitoring is doing as well. It allows us to look after legacy systems, like I said, and if you have any compliance needs, you could potentially put a compliance agent inside and meet your regulators' requirements. Many of these agents are ready to go, off the shelf, and maintained by someone else, like these guys. With Container Pilot, this is how simple it is to run a monitoring agent. We can see down here, we have the co-processor section. I'm sure everyone here will recognize that command. And then we have a tasks handler, and we have post-stop. The tasks handler is basically for batch jobs. Here we use it to send a heartbeat to the Zabbix server. We're basically sending a container state key and the number 1. And then when the container shuts down, everything's just about to terminate. The post-stop handler fires off, and we invert that to a 0. I'm sure some of you will recognize this guy. I thought it appropriate with all the pushing and pulling that we've had in the UK recently. But also because of the windowing and performance issues that we've had when we were pulling our metrics, I thought it quite appropriate just to cover some of the nuances we had between pushing metrics versus pulling metrics. When we started to look into this, we were using both approaches independently. Our push model was a single snapshot object which was sent to Liberato, and it was handled by DropWizard, the third-party library which runs, which is built into the application. Our pull model was a Zabbix agent which was installed on the virtual machine, and it was querying DropWizard's local web interface to pull the same object down, and it was processing the data out of that object, looking for the value that it wanted. The push model was certainly really lightweight, but it was opinionated and it was hard-coded, and you never really ever have any confidence in the state of the application. We also didn't particularly like Librato's event management system either. It's nowhere near as good as Zabbix's. Our pull model wasn't opinionated, could be configured dynamically, and it's much easier to understand the state of the applications in the environment. However, as I mentioned, with lots of individual requests, all post-processing a large JSON object, we found high CPU utilization issues. And then when we wanted to compare and calculate, say, error rates, we needed to compare errors versus all requests. We sometimes found values like 300% error rates when we had some particular issue in our environment. So both have their pros and cons, but I began to wonder whether there was a different way. I wondered whether we could get more of the benefits of both approaches, and this is where the Concierge came in. The Concierge is not a little man with a huge delivery, but it is a small script with a big delivery. And it's executed by the monitoring agents running inside the virtual machine or inside of a container. The courier has two jobs. First, it collects and delivers a manifest of what needs to be monitored back to Zabbix's discovery function. It then takes a single request to collect all the items from that manifest and push them all in one go to Zabbix. Then it records the success and how long it took back to the original requester. So with one request, collecting all metrics in one go, we'd immediately got rid of our windowing issue, but we were definitely doing some processing still. So this was a concern. So we tested it. Oops. So we have some CPU stats, we have some memory, and at the top left up here, we have the time that our courier records for how long it took to collect all the metrics. This is while we were collecting 17 metrics every 30 seconds. Now, we deliberately kept the conditions tight. We only gave the container, these are our container stats, we only gave the container 20% of an i3 processor and only 128 mega RAM. Also, even though the courier was, the script was also a proof of concept script, so it was literally the first tests that we were doing, and it was reading and writing to files on a disk, so we were doing I/O. So the conditions were pretty bad for the script, really. So this was our benchmark. And then we started pushing up our metrics, and we got up to 34,000 metrics every 30 seconds. And our CPU went from this to this. Barely 4%. Our load went from this to this, 1%. Even collecting metrics and reading and writing files to a disk, it only took around about a second for every extra 10,000 metrics that we added. And this was the full dashboard when we were collecting all the metrics. You can see some bytes out of memory, and we can see the extra load on the being sent over the wire. Now, we don't generally recommend you're collecting 34,000 metrics from your application, particularly if it's running in a container that small. Plus, we knew that there was a lot of optimizations that we could make to the script. I/O was an obvious one. So overall, we were pretty happy with these results, and it got us wondering what else this meant to us. So let's think about it a second. We've got a Zabbix agent there, so we get features like discovery out of the box. It's very easy for us to discover any Docker volumes, any extra network interfaces that are in the container. By pushing and pulling metrics, by using both approaches, it's very easy for a developer to simulate a production-like environment on a laptop. And with a couple of really simple additions to the script, we realized that we could do a couple of other things. If we wanted to, we could send metrics to multiple endpoints, or we could have it return the metrics if we pass a debug flag or something. So we could use Zabbix get and query the agent from some remote troubleshooting location for ad hoc debugging. All of this makes the approach pretty versatile, in my opinion. So if we have a look at the code, whenever we bring on a new employee, that employee needs to have a job description. One of the courier's responsibilities is manifest management. And this is the job description for that. It's just 8 lines of code. Then, when requested to do so, our courier has to pick up the items from that manifest and deliver them to their destinations. Then record the success of the delivery and the time back to the requester. And this is the job description for that. Only a few more lines, really simple. Some of you have perhaps noticed that we with open lines here, this is clearly our proof of concept script. We've actually done a lot more development to the script since then, but I like keeping this one up here, partly because it fits on a presentation screen, but also it shows exactly how simple it can be. So every good concept needs to have a good name, and I didn't really like the push and pull method. So, because of some of the thought process I'd had around accurate single shots and getting the immediate feedback with the timer, it felt to me like I was using a sniper rifle, getting feedback through the sight, as opposed to maybe a shotgun, which is probably quite accurate, but you've got no sight on a shotgun, you can't see that long distance, or even worse, a machine gun, an AK-47, which is firing off lots of different shots and not particularly accurate. So being British, it felt appropriate to me to name this after a well-known British sniper rifle, which some people may know from some computer games. The ENFIELD method gives us a range of benefits from both approaches. The pulling allows us to trigger on failed or slow requests and potentially detect network-wide issues and back off our checks, or at least reduce the network traffic by not sending lots of metrics all the time. Pulling allows us a central place to control metric timing and reconfigure our monitoring without having to reconfigure the application and redeploy everything. Push and pull together, we gain extra confidence in the state of everything that we're monitoring. And having the performance of pushing all metrics in one go, we can reduce our interval collection times, and by doing that we get more accurate metrics, we get less smoothing across the graphs, and that accuracy and that speed allows us to potentially react more quickly to events. So one of the main drivers for using containers is for running microservices. And many microservice applications are designed to be stateless. What's often forgotten in this design, though, is that we don't suddenly become stateless. Even though one or many applications in our environment are stateless, the system as a whole has a lot of state. Forgetting about databases for a minute, all of those applications have a current state, the performance that they're running at, the utilization they're running, and the number of those applications that are running in our environment right now. And this is probably some of the most fundamentally important pieces of state information that we actually have. How it looks now, how it looked before the last event, how it looked this time last week, and how we expect that it should look right now. Under the Concierge Paradigm and using the monitoring systems like Zabbix, where we've got everything in one place, we now have a really accurate live and historic view of the state of the whole system. And keeping this information together allows dev and ops to collaborate more easily on the same data using the same tools if they want to. And making the information easily accessible to other systems means that we can manipulate the state. With all this information in one place, it's easy for us to find out a lot of information about our current running assets and our recently terminated assets, and lots of information about both of them. So it soon became apparent to us that we've actually got everything we need to solve the last of our original problems. And we did it, did we? With another very simple script. which acts as a personal assistant to our event manager. Oh, missed that one. Let's quickly remind ourselves about what's been going on. We have containers which are auto-registering to notify their existence to other containers and our event manager. We're using an event management system which has been highly optimized over many years. 18 years, Alexei, did you say? 18 years. We use a common monitoring approach, which probably a lot of people do, where we're grouping together same purpose containers and applications into services using host groups. And we have this big asset database with a ton of information in it. So all the script really had to do was run Docker compose scale or Docker update whenever there was a suitable scaling event. And because the paradigm is an extending an already mature system, those events can have highly detailed profiles. We can use so many different metrics across so many different functions, and we can use things like predictive functions where we can actually look at the state of our environment last week and pre-scale our containers. We can potentially scale across multiple services. So if I give you an example, imagine we've got an application that we want to scale based on queue depth. But that application is talking to an upstream database, and that upstream database has performance issues. There's a very strong possibility that that queue depth is because of the poorly performing database. We don't really want to be throwing more applications out there. Because we're running containers, we also get the flexibility of being able to vertically scale. We can add more CPU. We can add more memory if we need to. And using trigger escalations in Zabbix means that if we perform some scaling event and it doesn't have the desired effect, we still need more. We can keep repeating those actions until we get back to an okay state. So there's no other single approach that I've seen that gives you this level of flexibility. The script, this one, is so simple. It really does fit up on a presentation screen. So here's a timeline of containers under the Concierge Paradigm. I've left Container Pilot out of this diagram for brevity. So when our container first spins up, the first thing that our partnership of agent and courier do is talk to the Zabbix server to register themselves. They then get information and go about doing normal system monitoring. One of the responsibilities is to pick up a manifest. So it goes about and does that and sends it to the Zabbix server. Then upon request, the pull method, it goes and picks up all of the items from that manifest and then sends them off to the Zabbix server as well. Now, if we get some event where we need to scale our environment, the Zabbix server will pass the required information onto the scheduling assistant, which will spin up more containers, and the life cycle continues again. Excuse me, I'm just going to open some water. Now, ultimately, we automate a lot of the following work in templates and in code. But let's have a look at what's going on the scenes in Zabbix. So no courier can perform their job if they don't have a manifest of what things they need to be delivering. So first things first, we need to go and get the manifest. And we do it using Zabbix's discovery function and the corresponding function inside of the script. Next, we need to define a blueprint on how we're going to interpret and accept all the items we want from the manifest. You'll note here that these items are all trappers because we're pushing metrics. And as soon as we receive our first manifest, our blueprint is used to create all the delivery addresses which we'll send to shortly, all of them being trappers, all done automatically. And of course, our courier needs a rotor to tell him when he's working. Here he's working every minute in this example. And we're pulling agent ping and the timers. We're using a passive agent to do that. And here you'll also see container state, which is a trapper, which is being sent from our task handlers by Container Pilot. These are the only static items that we set. And this is how the courier handles that. After our items have all been delivered, these are the expressions that tell the event manager whether or not some localized action needs to happen in that container. Maybe we give it some more CPU, or maybe it's terminated and we move it into a different host group and archive its monitoring data. We've got 2 triggers which are on get timers if it fails or if it's running slowly. We have 2 container states. We've got a 0 if post stop managed to send us a termination message. We also have a timeout on that because we can't guarantee that containers will always terminate gracefully, so we put a 2-minute timeout on it. CPU utilization. And here, this is basically looking to reduce that 2-minute timeout. We're putting a minute timeout on agent ping and a minute timeout on container state. This is kind of another feature of the ENFIELD method. By using both approaches, we're basically saying, well, we haven't heard from the container for a while, so we'll pick up the phone and give them a call. If the concierge answers, we'll give them a bit more time, the 2 minutes to respond, but if he doesn't, we'll just consider that you've both left the building. And after we set up Zabbix to work out individual containers, we need to define the services in our infrastructure. And we do this by grouping containers together which have similar DNS names, but you can use host metadata. And here we have console, and we're aggregating different metrics. The top one is one of the most important ones, and the bottom one, we've got 2 sums where we're counting the number of containers that we have in our environment. And we've got some of our state information here. Sometimes we also group by container version as well, so it's much easier to do comparisons against release versions. And once we've got all those items in place, we map the returned values to inventory fields and pass them off to our scheduling assistant. It uses the values then to scale our environment. Here we've got host.host, which is the name of our dummy host, which we've set up. In this case, it's console. We name our dummy hosts after the services. And we've got inventory.deployment status, which is auto-populated by container state. So we're passing this information, scale up, console. Current status is, 5 console containers running, and add 1 to it. And then here, we scale up. Then we have some triggers on the scaling events as well. We scale up on CPU load, scale down on low CPU, and we have a container state just recording all the events as they happen, because sometimes containers just terminate unexpectedly. So I don't actually think I've got much time for a demo. Let's perhaps have a quick look at what we've got. So I pre-started an environment. It's just because I expected this might happen. So we're running Docker Compose up. We can have a quick look at the compose file. Can everybody see that? So we have console. We're passing some key information about where the Zabbix server is, because console is going to register with Zabbix. We have MySQL, which is also going to register with Zabbix, and you can see some dependencies on different containers as well. We have the Zabbix server with some data. We also import our templates and host groups from config.import and config.export. So we have an API address there where we can do so. And then we have the web server. And we can probably quickly have a look at that. So here we can see 3 containers that are registered. We're currently looking at Zabbix. We can see that we've discovered 2 network interfaces, some CPU memory, and here is our fake APIs, which it went off and discovered, and some fake metrics. We also have container state as well. So here we can see our container state. And then just to finish up quickly. So in conclusion, once we'd considered the autopilot pattern and the ENFIELD method, the concierge paradigm and running containers quite simply just seemed to fall into place because we were already doing pretty much everything. And because because we were pretty much doing everything, and you probably are too, if you're not and you're using Zabbix, you've got the ability to do it. There's very few extra new things to learn and build, so getting something operational is really quick. Where do we go from here? We're looking for like-minded people to get involved. People who, just like me, believe in keeping things as simple as possible. We'll put much of this into GitHub very soon once we've taken out all of the company stuff, which we don't want to make public. And we'll have Ansible playbooks so that you can play around to your heart content, feedback in the true tradition of open source. So I understand that there's perhaps quite a lot in this short space of time, so please feel free to ask any questions, and here are a load of ways to get involved. Please follow us on Twitter, and we'll keep you updated as we send GitHub details out. Thank you.
Thank you, Gareth. Now it's time for questions from Slido.
Okay, thank you. So we have two questions. And the first is, can the autopilot pattern be used with the virtual machines?
Yes, very much. In fact, Google have a similar pattern. So we're currently working on a Google Cloud project for a large bank at the moment. And they actually have a pattern on their documentation, which is a very similar sort of approach. And they're using systemd for it. So it allows you to actually, using this method with your containers, allows you to merge and virtual machines and containers in all the same environment using the same approach, yeah.
Thank you. How this will work if your application doesn't use Drop Wizard?
It depends on. So what we're going to do with the concierge paradigm is there's some common interfaces that so Java applications use. You'll have Spring, and then there's Prometheus interfaces, and there is, and then Drop Wizard. We'll make those kind of de facto, but also give the ability to drop in a template to the script as well, which will allow you to make it a bit more personalized. The idea is that generally it reads some sort of JSON from your or a file or whatever it might be. So it's very flexible. You could quite easily adapt it to almost anything.
Hello.
I'm terribly sorry. I'm kindly asking you to stand up, please. Thank you.
Sorry,
You've got to get on camera, that's what it is.
I saw you're mainly using Zabbix as a more detection and transport layer for the metrics, but it's not like a storage engine for the metrics. Are you looking at other solutions? Because
For the storage engine for the metrics?
Yeah, because at the end, if I understood correctly, you're automatically discovering the metrics, and you're using Zabbix just to transport them to Zabbix. And then you want to visualize them, right, in Zabbix?
Yeah.
But, Zabbix is not made for storing large quantity of metrics. Have you had any issues?
Why is it not? Well, why is it not made for storing large quantities of metrics?
It's mainly the database is not made for that. Well, I don't know. In our case, we are not able to
okay.
store.
What is it? Have you partitioned your database tables? Yeah. Okay. We stored quite a lot.
So you guys are not having any issues with...
What sort of issues? I think that's probably a separate issue. So we use it for monitoring, yeah. Okay. You should probably talk to the Zabbix guys.
Okay, so...
Are you still using files before you send the data to Zabbix, or you?
No.
Because you imply that it's not very performant.
As you can see, it was still acting pretty well, but we don't want to do that generally. One of the parameters which would get passed into the script is a URL for the local interface, and that's a local drop wizard interface, Spring interface, Prometheus interface, whatever it's going to be. And if you've got that ability to do that and your application has that ability, so including drop wizard gives you that ability immediately, a local admin interface, querying that is much quicker than trying to do I/O. So you just pass a URL in, and that's already done. It's just not on here.
So thank you very much for the questions. More questions during the coffee break in person. Thank you very much, Gareth.
Thank you.